Hello everyone, good afternoon. I am Nikunj, your physics faculty from QNI, and I welcome you all to the QNI class. How are you all? Good morning everyone. Okay, so let's start today's lecture. So before starting the lecture, first we will see what are the prerequisites. Okay, we are studying chapter light, and if we talk about the prerequisites, so first one is object. Okay, then what is image? Okay, then about refraction of light. This thing we already discussed. Okay, what is object? The point of intersection of incident rays is called object, and the point of intersection of reflected or refracted rays is called image. Okay, and we also discussed about refraction of light, that when light enters from one medium to another medium, it bends, okay, because of the change in velocity. Yes or no? Is all these things clear to you? Yes or no? Okay. And if we talk about the weightage, so approximately 10 marks question asked from this chapter. Okay. Now, what we're going to study today? First, we will see about refractive index, then about lenses. Okay. Then we will see the distinguish between convex and concave lens, and we will solve some questions also based on the topics. Okay. Now, in the last class, we were discussing about the refractive index. Now, what is the meaning of refractive index? Anyone? What do you mean by refractive index? We know more is the refractive index, denser is the medium, and if medium is denser, then light will bend towards the normal. Yes or no? More is the denser medium, more will be the bending towards normal. Okay. And at last, in the last class, we were discussing about the refractive index of some materials. Okay. Now, what do you mean by absolute refractive index? Means refractive index with respect to the vacuum. Okay, if we talk about the air, so for air, refractive index is equals to 1.003. Similarly, for vacuum, it is approximately 1.31. For water, it is 1.33. Similarly, for crown glass, it is 1.52, and for rock salt, it is 1.54, and for diamond, it is approximately 2.42. Okay, so what is the conclusion? So as the refractive index increases, the bending capacity increases. I hope this is clear to you. Any doubt till here? Clear? Okay, very good. Now we'll see some formula for the refractive index. Okay, we know NAV means refractive index of air with respect to vacuum. And if we are talking with respect to vacuum, that means we are talking about the absolute refractive index. Okay, we are talking about refractive index with respect to any uh, with, res with respect to vacuum of any medium. So that's the absolute refractive index of that medium, because refractive index with respect to vacuum is nothing but the absolute refractive index, because refractive index for vacuum is equals to 1. Okay. Now we know that refractive index with respect to vacuum is equals to velocity of vacuum upon velocity of light in air. Now what is the velocity of light in vacuum? So this is equals to 3 into 10 to the power 8 meter per second. And if we want to calculate velocity of air, speed of light in air, so this is equals to velocity of light in vacuum upon refractive index of air with respect to vacuum. And as we know that refractive index of air with respect to vacuum is slightly less greater than 1. Refractive index of air with respect to vacuum is slightly greater than 1, which is 1.003. So speed of light is slightly less than 3 into 10 to the power 8. Okay, is this clear? Yes or no? Is this clear? Very good. Now, if we talk about the refractive index of ice with respect to air, now this is not absolute refractive index, because here we are talking about the refractive index of ice with respect to air. And for air, refractive index is approximately equals to 1.003, not equals to 1. So this is not absolute refractive index. So here we will say that refractive index of ice with respect to the air, which is equals to velocity of air upon velocity of ice. Okay. Similarly, refractive index of glass with respect to vacuum. Again, here we are talking about with respect to vacuum. That means we are saying absolute refractive index of the glass. Okay, because here refractive index with respect to vacuum. And what is the refractive index of glass with respect to vacuum? So this is equals to velocity of vacuum upon velocity of glass. Okay. Now, if we talk about the velocity of water, or we can say refractive index of water with respect to air. So this is equals to velocity of air upon velocity of water. And if we're talking about the refractive index of air with refracting index of oil with respect to air, so this is equals to velocity of air upon velocity of oil. Okay, so these are the some formulas. Okay, simply we have to know that the refractive index of one medium with respect to another is equals to velocity of another medium upon velocity of medium one. Okay, velocity of refractive index of medium one with respect to two is equals to velocity of speed of light in medium 2 upon speed of light in medium 1. Okay, is this clear to everyone? Any doubt in this, that what is the meaning of absolute refractive index or refractive index of one medium with respect to another medium? Any doubt in this? Yes or no? Very good. Now we will solve some questions based on the refractive index. Okay, before that we will see a general formula that refractive index of medium 2 with respect to 1 is equals to velocity of light in first medium upon velocity of light in the second medium. This is the velocity of light in first medium. This is the velocity of light in the second medium. Okay, and what is this? So this is the refractive index of medium 2 with respect to 1. And we also know that refractive index of medium 2 with respect to 1 is reciprocal of refractive index of medium 1 with respect to 2. Okay, now there are some important points. If the first medium is not mentioned, as I already said, that take first medium as air. By default, if medium is not given to you, then we will consider that medium as air by default. Okay. Now, if the first medium is vacuum, then refractive index of second medium is called as the absolute refractive index. This point we already discussed. Okay. Now the next, for solving numerical velocity of light in air, we take approximately equals to velocity of light in vacuum, which is 3 into 10 to the power 8 meter per second, because we know that refractive index for vacuum is 1 and for air it is 1.003, which we can say approximately equals to 1. So velocity of light in air is slightly less than 3 into 10 to the power 8. We can say for calculation part, we can take as equals to approximately 3 into 10 to the power 8. Okay. And refractive index. Now refractive index of medium 2 with respect to 1 is equals to velocity of light in medium 1 upon velocity of light in medium 2. So refractive index is equals to ratio of velocities. Now, what is unit of velocity? Meter per second. What is unit of velocity? Meter per second. So this cancels out. So refractive index has no units because it is the ratio of same physical quantity. Refractive index is the ratio of same physical quantity. So it is unitless. Is this clear? Is all 3 points clear to you? Any doubt? Clear? Okay. So for calculation part, we take approximately velocity of light in air is equals to velocity of light in vacuum, which is 3 into 10 to the power 8. And by default, if nothing is mentioned in the question, then we will take air as a medium. Okay, very good. Now we'll solve some question. So first question is, light enters into a glass plate having absolute refractive index 1.50. What is the speed of light in glass given the speed of light in vacuum is 3 into 10 to the power 8 meter per second? Okay, one more thing. At the end of the class, we will practice for half an hour. So please don't leave the class. Okay. At the end of the class, we will practice some questions on the platform in the class itself. Okay. So everyone has to log in on the platform and I tell you which topic you have to practice on. So don't leave the class. Okay. Is this clear to everyone? Yes or no? Okay. Very good. Very good. Now solve this question. Find the speed of light in glass. What is the answer? Anyone with the answer? Use the formula that refractive index of glass with respect to vacuum is equals to velocity of light in vacuum upon velocity of light in glass, and solve this question. Okay, anyone with the answer? So refractive index of glass with respect to vacuum is equals to velocity of light in vacuum upon velocity of light in glass. Yes or no? So can we write that velocity of light in glass is equals to velocity of light in vacuum upon refractive index of glass with respect to vacuum. Now, if I'm saying that refractive index of glass with respect to vacuum, that is the absolute refractive index, and we know that speed of light in vacuum is equals to c. Okay, c means velocity of light in vacuum, which is 3 into 10 to the power 8. Can we write this is equals to c upon refractive index of glass? Now this is equals to 3 into 10 to the power 8 upon what is the value of refractive index? 1.5. Okay, so 3 upon 1.5 is equals to 2. So can we say that velocity of light in glass is equals to 2 into 10 to the power 8 meter per second? This is your answer. Anyone having doubt? Yes or no? Is this clear? Yes or no? Raghavi, any doubt? Okay, now we'll solve next question. Given refractive index of water is 4 by 3 and speed of light in air is 3 into 10 to the power 8 meter per second, find the speed of light in water. Everyone solve this question. Find the speed of light in water. Now what is the answer? Tell me. Raghavi, Joven, Rahul, Devi Maya. What is the answer? Everyone, please solve this question. Is there any confusion in using the formula? Tell me, is there any confusion in using the formula? Yes or no? Is there any confusion or any doubt? Okay. Now given refractive index of water and given speed of light in air, so refractive index of air with respect to water. Yes,
So the
Raghavi.
answer is 2.25 into 10 power 8 meter per second.
2.25.
into 10 power 8 meter per second.
Okay, very good. Now this is equals to refractive index of air with respect to water is equals to velocity of light in water upon velocity of light in air. Yes or no? Is this clear? So can we write, is this clear? Okay. Now we can write velocity of air, sorry, velocity of light in water. This is equals to refractive index of air with respect to water. Can we write this is equals to 4 by 3? Sorry, refractive index of water with respect to air, na? Refractive index of water with respect to air. Refractive index of water with respect to air. This is equals to velocity of light in air upon velocity of light in water. Okay. So velocity of light in water, this is equals to velocity of light in air upon refractive index of water with respect to air. Now given this is equals to 3 into 10 to the power 8 upon 4 by 3. Yes or no? Now this is equals to 9 upon 4 into 10 to the power 8, which is equals to 2.25 into 10 to the power 8 meter per second. Here you can ask me a doubt, sir, this is not absolute refractive index. Then why it is equals to 4 by 3? If we take refractive index of water with respect to vacuum, then that equals to 4 by 3. But here we have taken refractive index of water with respect to air is 4 by 3. But for only calculation part, okay, in real terms, this is not equals to 4 by 3. Okay, it is slightly more than 4 by 3. Yes or no? Refractive index of water with respect to vacuum is 4 by 3, na? Yes or no? But as I said, for calculation part, we can take approximate velocity of light in air is equals to velocity of light in vacuum. That's why I have written that velocity, refractive index of water with respect to air is 4 by 3. Okay, only for calculation purpose. In reality, this is not equals to 4 by 3. Okay, because this is not absolute. Yes or no? Is this clear to everyone? Okay, very good. Now, next question. If the refractive index of water for light going from air to water is 1.33, then what will be the refractive index for light going from water to air? Tell me. What will be the refractive index for light? It is reciprocal of 1.33, yes or no? We know that refractive index of one medium with respect to 2 is equal to refractive index of second medium with respect to 1. Yes or no? Yes, 0.75. So this is equals to 1 upon 1.33. Okay, which is equals to 0.75. Yes or no? Any doubt? Is this clear? Now why it has changed? Because in first case, light is going from air to water, that is from rarer to denser medium. Okay. But in the second case, light is going from water to air, that means from denser to rarer medium. And if light is going from denser to rarer medium, its velocity will increase. And if velocity is increasing, that means refractive index will decrease. So in the first case, light is going from rarer to denser medium, so refractive index of denser medium is more, so speed of light is less. That's why in the first case refractive index is 1.33. But in the second case, light is going from water to air, that means from denser to rarer, so it will bend away from the normal. That means speed of light will increase, so refractive index will be less with respect to the first case. Yes or no? That's why here the refractive index is 0.75 and in the first case refractive index is 1.33. Okay, clear? Yes or no? Okay, next question. Given the refractive index of kerosene, turpentine and water are 1.47, 1.44, sorry, and 1.33 respectively, in which of these materials does the light travel fastest? Tell me. In which of the material light will travel fastest? So the answer is yes. Raghavi, what is the answer? Joven, turpentine. Light travel fastest for which medium? Which have low refractive index? Yes or no? Yes, water. We know as refractive index will increase, that means medium is denser. And if medium is denser, then velocity of light is less for denser medium. But if refractive index is low, that means medium is rarer. Okay, that means velocity will increase. So here we are asking that in which light will travel fast. So which have low refractive index. And if we see 1.33 is the lowest here. Okay, that means light will travel fastest in water. So the answer is water. Yes or no? Rahul, is this clear? Rahul, is this clear? Any doubt? Okay. Next question. In which of the given media light moves the fastest? Water, ice, alcohol, and the respective refractive index given in the table. In the second part, calculate the velocity of light in water. Calculate the velocity of light in water. Okay, ice. Very good. So the answer for the first is ice because for ice has a lowest refractive index, and if refractive index is low, that means medium is rarer with respect to the other mediums, and for the rarer medium, light will travel fast in that medium. Okay, very good. Now second, calculate the velocity of light in water. Calculate the velocity of light in water. What is the answer? Refractive index of water with respect to air is equals to velocity of light in air upon velocity of light in water. Yes or no? Okay. Now, velocity of light in water, this is equals to velocity of light in air upon refractive index of water with respect to air. Now we know for calculation part, velocity of light in air is 3 into 10 to the power 8. upon refractive index of water with respect to air is 1.33. Now 1.33 is approximately 4 by 3, yes or no? So 3 upon 4 by 3, 3 upon 4 by 3 into 10 to the power 8, this is equals to 9 by 4, which is 2.25 into 10 to the power 8 meter per second. Is this clear? Okay, now calculate light of, is this clear? Second part is clear to you? First tell me, the second part is clear to everyone? Anyone having any doubt? Okay, very good. Now calculate the velocity of light in air with respect to ice. Calculate the velocity of light in water with respect to ice. Okay, can you calculate? Yes or no? Simply use the same formula. Okay, and you can calculate. Clear? Yes or no? Yes or no? Okay, very good. Now solve this question. Given the path of light passing from air to different media A, B, and C for a given angle of incidence is shown below. Study the diagrams and answer the following questions. First, which of the media A, B, and C has a maximum optical density? Second, through which of the media will the speed of light be maximum? And the third part, will the light traveling from A to B bend towards or away from the normal? So everyone please solve this question. Okay, what is the answer for the first part? In which of the media A, B, and C has a maximum optical density? Optical density maximum means which medium has more refractive index? Medium C. First, tell me the answer for first part. It is medium C or medium A? Optical density more means more refractive index, and if refractive index will is more, that means light will bend towards the normal. Yes or no? If refractive index is more, that means light will bend more towards the normal. Yes or no? If light is bending more towards the normal, okay, tell me, suppose this is your normal. Let's say this light is incident on it. This is angle I and this is angle R. If light will bend more towards the normal, in that case, angle of refraction or angle R is more or less. If light will bend more towards the normal, in that case, angle R will be more or less. Tell me, if light will bend more towards the normal, if light will bend more towards the normal, in that case, angle of refraction is more or less. Less. Yes or no? If light will bend more towards the normal, that means this angle will less, na? Yes or no? If this angle is less, that means light is bending more towards the normal. That means that medium has a more optical density. That medium has a denser medium. So in which medium light is bending more towards the normal? In which case angle of refraction is less? For which medium angle of refraction is less? Tell me, for which case? Yes, medium A. Here angle of refraction is 30 degree, here 45, and here 40 degree. So that means angle of refraction is less for medium A. That means light is bending more towards the normal in medium A. So can we say that optical density for medium A is greater than, now for C angle R is 40 degree. So medium A, then medium C, and then medium B. Yes or no? This first part clear to everyone? Yes or no? Any doubt? Okay. Now second question. Through which of three media will the speed of light will be maximum? So which has lowest refractive index, in that medium speed of light will be maximum. And if medium has low refractive index, then light will not bend towards the normal, it will move away from the normal. And or we can say, if angle of refraction is more, that means that medium has low optical density, that medium has a rarer medium. In that case, speed of light will be maximum. So tell me, for which medium speed of light will be maximum? Rahul, for which medium angle of refraction is more, A, B, or C? Rahul, for which medium angle of refraction is more, A, B, or C? Tell me, for which medium angle of refraction is more? For medium B, yes or no? For medium B, angle R is more than medium C, more than medium A. Yes. So that means medium B is rarer than A and C. Yes or no? And if medium B is rarer, in that case, the speed of light will be maximum. So can we say, for second case, speed of light will be maximum in medium B, then medium C, then medium A. Yes or no? Is this clear? Speed of light will be maximum in medium B, then C, then A. Yes or no? Is this clear to everyone? Any doubt in this? Yes or no? Anyone having any doubt in this? Okay. Now, third part. Will the light traveling from A to B bend towards or away from the normal? Now we have to compare for medium A and medium B. Okay. Medium, tell me which medium is denser, medium A or medium B? Which medium is denser, medium A or medium B? Let's say this is medium A and this is medium B. Now which medium is denser? Medium A is denser and medium B is rarer. Yes or no? Angle of refraction is less than is less in medium A as compared to B? Yes or no? Angle of refraction is less in medium A as compared to B? Yes or no? And if angle of refraction is less in medium A, that means medium A is denser than medium B. Okay. Now, if light is going from denser to rarer, if light is going from denser to rarer, then what will happen? Tell me. If light is going from denser to rarer, what will happen? It will bend away from the normal. Yes or no? If light is going from denser to rarer, can we say that it will bend away from the normal? If medium B is denser than A, then we can say, yes, if light is going from rarer to denser, then it will bend towards the normal. If light is going from denser to rarer, then it will move away from the normal. Yes or no? So is this question clear to you? And by after solving this question, all your concepts of refraction was getting revised. Yes or no? Okay. So please take care that if medium is denser and if light is coming from rarer to denser, then angle of refraction will be less because light is bending towards the normal. Okay. And if light is going from denser to rarer, then light will bend away from the normal. And in that case, angle of refraction is more. Yes or no? So please take care of the angles. Okay. If like this question given that there are several mediums and if medium is not mentioned, but we know what is the angle of refraction for different mediums. Okay.